In this video, we will learn how to balance redox reactions in acidic and basic conditions using the half reaction method. So let's pause for a moment and think about whether the reaction below is balanced. Pause the video and think about this. Check carefully. This reaction is not balanced. And that's because if we look over here, the overall charge of everything is -1. If we look over here, the overall charge of everything is +2. And so that's a difference of 3 electrons. Where did those electrons go? And so we can't destroy electrons, and so this reaction's not balanced. We have to pay attention to the charges, not just the atom counts, to ensure our reaction is balanced. So there's a process for balancing redox reactions that will help us ensure that we are not losing electrons in the process. And so this is known as the half reaction method. And I'll be going through each of these steps in an example problem. But it will begin by splitting into half reactions, and then we will work on balancing all the different aspects of the reaction. We will be doing acidic conditions first, and then converting acidic conditions into basic conditions. The first step for this half reaction method is to assign oxidation states to all of the elements. This is hydrogen peroxide, and so the oxygen here is a -1, and the hydrogen is a +1. Oxygen in permanganate is a 2-, -2. There's 4 of them, and so 4 times -2 plus whatever manganese is, and that's going to be equal to -1, and so manganese is a +7. Manganese here is equal to its ion charge of 2+, and that's a 0, and then I have a -2 and then a +1. And so we've assigned oxidation states to everything. And so we can tell from this that the manganese is being reduced because it's going from a +7 to a 2+. And we can see that oxygen is also changing oxidation states. It's going from a -1, and -1 doesn't exist on this side. And so we can see that this oxygen in particular is changing from a -1 to a 0. This oxygen is a -2, and that oxygen is a -2, so that oxygen isn't a change. We are looking for things that do not exist on the other side. So now that we know the oxidation states for everything, we can split into half reactions. If you're paying attention closely, you might notice that there was water earlier, and now there's no water. The water will come back as we begin to balance, but for now we're only concerned with the particular substances that were undergoing a change in oxidation states. And so manganese was being reduced, and so I'm going to put that in the half reaction for the reduction half reaction. And both of those were aqueous. And then the hydrogen peroxide forms the O2 gas. The next step for balancing these redox reactions is to balance all of the elements that are not oxygen and not hydrogen. For our oxidation half reaction, we only have hydrogen and oxygen, and so we are done with this step. Woohoo! And so we're done with that step. Here we look and we like, okay, we got the only element that's not oxygen or hydrogen is manganese. I have 1 manganese here, 1 manganese here, and so I'm done with this step. The next step in our half reaction method is to balance out the oxygens with H2O. And so I gotta add H2O to wherever I need more oxygens. Here I have 2 oxygens and 2 oxygens, and so I'm done. I don't need to add any water there. Here I have 4 oxygens on the reactant side, and on the product side I have 0 oxygens. And so that means I have to add 4 waters to this side so that I have 4 oxygens and 4 oxygens. Now I have finished this step. Oh, water is also a liquid. The next step for our half reaction method is to balance the hydrogens with H+ ions. So if I count the hydrogens here, I have 2 hydrogens on the reactant side. I have 0 hydrogens on the product side. And so that means I need to add 2 H+ ions, aqueous, to the product side so that I am balanced. Now I need to balance out this one. Since I added the waters over here, now I have 8 hydrogens. And so I have to come back over onto the reactant side and add 8 H+ ions to balance out my hydrogens. And those hydrogen ions are aqueous. The next thing we need to do is balance out our charge. But we need to know what the overall charge is on each side of the reaction. And so the reactant side here, all of the compounds are 0, and so no charge, and so it adds up to 0. Here we have something that's a 0 charge and 2 things that are a positive 1 charge. So that's going to count as 2 positive, and so that's going to add up to 2 positive. So you got to distribute out your stoichiometric coefficients. Now we have to add up everything on the reactant side and then everything on the product side. We have 8 things that are +1, and we have 1 thing that is a -1. And so that's going to add up to +7. And over here, this is going to add up to 2 positive. The water is neutral. So now that we have the overall charge, we can add electrons in order to make the charges equal on both sides. So if we look at the first one, we see that this side's a 0 and this side's a 2 positive. Electrons are negative, and so when we add electrons, it's only going to lower the overall charge. So I have to match the lower of these 2 numbers. This is a 0, so I have to make this 0. I can make that side 0 by adding 2 electrons. Now I added 2 negative charges, and so it will add up to 0. For this one, this is a +7, and this is a 2 positive. That means I have to add 5 electrons to that side so that it's equal to the charge on that side. I have to add 5 electrons to that side of the equation. We can also help remember that oxidation is the loss of electrons. And so our electrons should be on the product side. And reduction is the gain of electrons. And so our electrons should be on the reactant side. Now we can see that we have 2 electrons being lost here, and we have 5 electrons being gained in the reduction half reaction. Now I can't gain more than I lost. I have to make these electrons equal so that the number lost is equal to the number gained. Now in algebra, if you do something to 1, you got to do something to everything. So I can't just change this to 10 and change that to 10 to make them equal. I gotta multiply the entire reaction by 5 to get up to 10. 10 is the lowest common multiple between 2 and 5. So now I have to distribute out and so I'll have 5H2O2 aqueous going to 5O2 gas and 10 H plus ions that are aqueous and 10 electrons. Now for the next one, I got to distribute out this too to everything. So it's going to give me 16 H plus ions that are aqueous and 2 MnO4 ions that are aqueous and 10 electrons. And then we have 2 Mn2 plus ions that are aqueous and 8 waters that are liquid. Now that our electron counts are equal, we can add our two half reactions together to get the overall equation. The most important thing to remember here is that when you're adding, you kind of have to remember where the arrow is. So everything on the reactant side will stay on the reactant side. Everything on the product side will stay on the product side. So let's just go ahead and write all that out. So 5H2O2 aqueous plus 16H plus aqueous and 2 MnO4 minus aqueous and 10 electrons. Then my arrow is down too low. So I have my 5O2 gas and my 10H plus aqueous and my 10 electrons and 2 Mn2 plus aqueous and 8 H2O liquid. Now this has some things that can cancel out. For instance, the 10 electrons on both sides. That can cancel out. This side has 16 H pluses, this side has 10. So I can cancel out 10 of those H plus ions and be left with 6. There's no water to cancel out. So I should have 5H2O2 aqueous, 6H plus aqueous, 2 MnO4 aqueous, 5O2 gas. So that canceled completely. And then I'll end up with 2 Mn2 plus aqueous and 8 H2O. I should double check that this is balanced. And so I can see I got 2 manganese. Let's add up my hydrogens. That's 10 plus 6, which is 16. 8 times 2 is 16. 5 times 2 is 10. Plus 8 more is 18. And I got 10 plus 8. So I'm balanced for atoms. Let's see about the charge to make sure I didn't mess up that. The overall charge here, that's 6, and that's 2 minus, so that's going to add up to positive 4. And then oxygen's neutral, the manganese is charged, that's 2 times positive 2, and so that's plus 4. And so I've checked my atom counts and I've checked my electron counts. And so this reaction is now balanced. So I'll go ahead and circle it, and woohoo! All that work to balance, and now it's really balanced. Now, if you're ever asked to balance a redox reaction in basic conditions, really you need to balance in acidic conditions first and then convert to basic. when you're converting to basic, you're taking advantage of an acid-base neutralization reaction by adding OH- until you cancel out all of the H+ ions to turn them into water. Then you'll have water molecules that you can cancel out because you might have waters on both sides. So let's convert our previous reaction into basic conditions. You can see that we were left with 6 H+. That's acidic. So I need to add the same amount of OH- ions in order to neutralize all of that H+. And that will leave me with 6 waters, because 1 H+ and 1 OH- makes 1 water. So if I write this out, I should have 5H2O2. I'm going to leave out the state symbols for now. That's going to be 6H2O, 2MnO4 minus, and then 5O2, 2Mn2 plus, 8H2O, and my 6 OH minuses. Now I got 6 waters here and 8 over there, so I can subtract to simplify the waters, and then I'll be left with 5H2O2 and 2MnO4 minus going to 5O2 gas and 2Mn2 plus aqueous and 2H2O and 6 OH minus. Here's a practice problem for you. You will balance this one in acidic conditions. I've put a kind of cheat sheet up here so that you can refer to it when you're trying to figure out the process. It will take some experience to realize how these flow together. I like to think about O with water, and then that gives me H, which tells me to balance H next. That gives me an H+, which tells me I need to add electrons next. But anyway, go ahead and pause the video and try to work this out on your own. Unpause when you're ready to continue. Okay, let's try to balance this. This is dichromate, and we have 7 times minus 4 and 2 chromiums. The chromiums are going to be positive 6 each, and that's going to be minus 2. That's minus 4 each, or minus 4 overall. And then that's a plus 1. And so my nitrogen here is going to have to be a positive 3 in order to cancel out. My chromium here, that's a 3 plus. That one was easy. Now we got 2 minus. There's 3 of them, so that means nitrogen's a plus 5. So my nitrogen is changing, and my chromium is changing. Chromium is getting reduced, and nitrogen is being oxidized. And so my oxidation half reaction is going to be about my nitrogen. So I can copy down HNO2 aqueous and leave myself room. And then my reduction half reaction is going to be regarding my chromate. So I got to make sure that I balance all of the non-hydrogen, non-oxygen atoms first. One nitrogen, that one's balanced, but here I do have to add a 2 to the chromium in order to make sure that I have 2 chromiums. Now I have to balance out the oxygens. I see 2 oxygens here, 3 oxygens here, so I got to add 1 water to that side of the reaction. This side has 7 oxygens, this side has 0, so I'm going to need to add 7 waters down here. Now I have to balance out my hydrogen counts. I have 1, 2, 3 hydrogens on that side, so I'm going to need 3 hydrogens on the other side, hydrogen ions. And so that's going to be aqueous. Now I'm going to balance out the hydrogens for the reduction half reaction. That is 14 hydrogens, and so I'm going to need 14 hydrogens down here. Now we balance out the charge. This side is neutral, this side adds up to neutral. No, that doesn't add up to neutral. That's a 3 positive. So that's 3 positive, and that's a -1. And so that adds up to 2 positive. That side still adds up to 0. So I'm going to need to add 2 electrons over here to bring it down and make both sides equal in charge. Now I have one thing that's a 2 minus, and that's a 14 positive, and so that's going to give me 12 positive. That is 2 times 3, and so that's 6 positive, and that's the neutral. And so I'm going to need 6 electrons in my reduction half reaction in order to make these sides neutral. This is 2 electrons, that's 6 electrons, and so I'm going to need to multiply this top reaction by 3 in order to make my electron counts equal. Let me switch color pens, and then I'll distribute out that 3. 3, 3, 3 times 3 is 9. That's a 3, and then that would become a 6. Now that my electron counts are equal, I can add my 2 half reactions together. I can also keep an eye on my waters and simplify as I go. Since I got 3 waters here and 7 here, I know that I'm going to cancel those out and be left with 4. So let me try to remember that as I'm adding these together. And so that will be 3HNO2 aqueous, and my chromate, and I can also simplify out my waters, or my hydrogen ions. That's going to reduce that to 5. And then that canceled out, so I'll be left with 3 nitrates, 2 chromiums, and 4 H2O. And so let's make sure this is balanced. 2 chromiums, 2 chromiums, 3 hydrogens here, plus 5, that's 8 total. And so I got 8 total. 3 nitrogens, 6 oxygens plus 7. 6 plus 7 is 13. And so I got 9 plus 4, which is 13. So I am balanced, and I can see that my charges add up to positive 3 on this side. And this side is, I think we're good. All right. So here's the equation, and you can see that we are balanced. That's supposed to be a 2 minus in there. Yeah. All right, here's another practice problem for you. This one says that the following redox reaction has been balanced in acidic conditions, and you're asked to convert it into basic conditions. pause the video and work this out, and then unpause the video when you're ready. All right, so if we're going to convert this into basic, I see the 2 H plus ions over there, so I'm going to need to add enough base to cancel that out, and so that's going to end up with 2 OH minuses on the other side as well. If you do something to one side, you got to do it to the other side so that it stays balanced. It's like just like in algebra, only with chemical equations. And then that is going to add, oh, I didn't actually write down my hydroxide ion. And that's going to get us to have 2 waters. This water and that water will cancel out. And so you'll be left with only 1 water on that side. Here's yet another practice problem for you. This one is multiple choice. It says, in the presence of acid, nitrate ion oxidizes solid copper to copper 2+. The byproduct is gaseous NO2, which is brown. The balanced half reaction for NO3 nitrate to form NO2 is blank, and then you have to work it out. That arrow is misplaced, isn't it? So that looks weird. I'll figure out what's up with that soon. But we can balance this just from the description. Pause the video at any point if you want to work out on your own. And so listen to me. So the nitrogen here is going to be a +5, and here it's a +4. So it is gaining an electron. And so we have to look to see which ones have electrons on the reactant side, which are not those. And I don't think it's this one, although I can't really tell with the formatting what happened there. I can balance out my oxygens with a water, and then that's going to give me 2 hydrogens, and so I'm going to need to have 2 hydrogens on this side. And so that is matching option C. All right, that concludes our video.